Hi, I'm Mr. Ziegler. I'm here to go through the separation techniques notes with you for chemistry. To start off here, a little bit of review. Using only particle motion, describe the difference between solids, liquids, and gases. So if we remember, solid is going to have particles that are tightly packed. They're going to be very close to each other. So that's telling us a little bit of a difference between some of the others. But using particle motion, these particles are just going to vibrate back and forth. They're going back and forth. They're not really changing their position. They're not sliding past each other. They're right next to each other, and they're just going to vibrate or go back and forth very quickly. Liquids, they have a little bit more space between them. And because they have a little bit more space between them, these particles can slide, or sometimes I say flow, past each other. So they don't move overly fast, but they are sliding past one another, and that's why liquids don't have a specific shape. It depends on what's holding them. So they might be able to slide left or right unless they're right next to, let's say it's water in a cup, they're next to a wall, they can't slide through the cup's wall, but they can slide past other water molecules. If you empty it out of the cup just on a table, then they can spread out all over the place and they make a different shape. Gases, these particles are a lot more spaced out, and they are moving very fast in random directions, bouncing off walls, doing different things, but they are moving the fastest in gases, and they're farther apart. All right, whoopsies. Here, describe the difference between a pure substance and an impure substance. A pure substance has one type of particle. That is it. Now, if you remember from one of our assignments, what is a particle? It could be a single element, so a single shape. This would be a pure substance right here. But it could also be a compound in which things are connected. That doesn't look very different. I'll do a better job here. A circle and a square that are connected. Now they might, that one's not really connected. There we go. There we go. All right. They might be kind of upside down or look a little bit different, but they should all be circle squares. Both of those are pure substances. This is a particle here. This is a particle here, and then everything else in this substance is the same particle. An impure substance is when we have more than one type of particle. So if I have a particle that's a circle and a particle that is a circle square, okay, even though the circle is here and the circle is here, it's a different particle. This is different than this, and so that would make it an impure substance. All right, list or explain a process you could use to separate a mixture. So if you think of some sort of mixture where we have an impure substance, we have multiple things that are kind of combined in a cup or on a plate or a bowl or something. What is something you could do to try to separate the different parts of that mixture? I want you to kind of come up with one on your own, because this separation technique notes are going to explain how you can do that with certain things. So let's get into separation techniques here. One technique is called filtration. Filtration is used to separate an insoluble, which means that it can't dissolve, an insoluble solid from a liquid. So a good example here would be a coffee filter. Okay, so a coffee filter, if you don't know, you put coffee grounds in here. So you take coffee and you grind it up. Okay, now it's still a solid. Okay, and you're going to pour hot water over it, and the water is going to take some of that ground up coffee and it's going to mix with the water. And when it mixes with the water, it goes through the filter. All right, but most of it will be left behind. Most of the coffee is going to be left behind because the chunks are too big or they don't dissolve in water. And so at the end, you take this coffee filter and you throw it in the garbage, okay, because it's got old coffee grounds in it. And so this separates the water from the coffee grounds, which are in here. That's my picture of coffee grounds. It's poor, I know, but it's the best I can do at this point. All right, but that's what filtration is. You might have also seen some old pictures of people who are, it's called panning for gold, where they have kind of a mesh kind of plate. They put it in the water, and the gold, because gold does not dissolve in water, can get caught in there, and other rocks and things get caught in there, and you can use that to filter the gold or the rocks out of the water. Evaporation can be used to separate things. It's used to separate a dissolved solid. Let me move my head here. From a liquid. So here's the process here. Let's say we have salt water here. Salt water. I should say this is water. Okay, water. This is salt. Okay, we combine them together to make salt water, and then we heat it up. And you can see the steam coming off here. And when we heat it up, what happens is the water evaporates, but salt has a different boiling point. Salt is extremely hard to evaporate. And so what's left behind in the beaker is the salt after all the water evaporates. You could do this with anything that dissolves in water and has a different boiling point. So you could do sugar. You could do lots of different things. That is our evaporation technique. Next, flotation. All right. If something floats and something does not float, you can separate them by putting them in water. So remember, water has a density of 1. So if we have two solids that have different densities, one above 1 and one below 1, you can put them in water, and one will float and one will sink. But we don't always have to use water either. We could use a different liquid. If a liquid has a density of 2, all right, we just need something that has a density lower than 2 and something that has a density higher than 2. And one will sink and one will float, and that'll help us separate them. Magnetism is another way to separate materials. So some things are magnetic, all right? And most people say metal is magnetic, and there's only a few metals that are magnetic. Iron is the one we normally think of, and that is put in a lot of other metals like steel, and that's probably the most common one that we see around. It's got iron in it, which makes it magnetic. If we would put that into something that is non-magnetic, we could pass a magnet over it, and the magnet is going to absorb the iron pieces or anything that's magnetic, and it's going to leave everything else behind, helping us separate the material. The last one we're going to talk about here, keep moving my head around, all right, is distillation. All right, distillation is used to separate two liquids with different boiling points from each other. So we must capture one of the liquids at the end. So what we can do here, this is water. We could say that maybe this is oil. Okay, I know they don't really mix together. That's okay. You could get two things that mix together. So water and, I don't know, something that's not water-based. Maybe an alcohol, like isopropyl alcohol, that rubbing alcohol. All right, and we can boil it. And we have to be careful with our boiling temperature, but we could boil off the alcohol, and then we need to somehow capture it. Now, one way to capture it is we could put something up here with ice. That makes it very cold. And so when the alcohol evaporates, it touches something that's cold, and then it condenses. And it condenses back into a liquid, and then we could put like a tray here or a slide, so that once it gets up here, it turns back into a liquid, and then it slides into a container here. And then what's left over will be water. Or if we're doing oil, all right, oil has a higher boiling point than water. We could evaporate the water and we can collect the water here, and then the oil would be left behind. And so we could separate two liquids from each other using distillation. All right, so that's all the information that we need to know for the test. So I want you to rank yourself here. How ready do you feel? All right, do you think you're a 0, a 1 to 2, a 2 to 3, 3 to 4, or do you think you're super ready? You're a 4 right now, all right? So we'll have a little bit of practice. We'll have a review, but be ready for a quiz coming up soon. I hope this helped, and I'll see you next time.